Hey everybody, and welcome to Semester 2 of Programming in the Forge. This week, we're going to ease back into things by taking a step back and looking closely at the art of problem solving. There are so many approaches to problem solving, and many of them make use of techniques specific to whatever field the problem is in. For example, solving a math problem probably uses different techniques than solving a relationship problem. Or does it? Let's do our best to look at some really high-level techniques that can apply to problem solving as universally as possible, making us much more efficient problem solvers. Now let's make very clear what we're talking about here. We are not talking about the scientific method, which is primarily for the purposes of observation. Now this method may be a step that can be applied to the still larger endeavor of problem solving, but we need higher level techniques than that. What we are talking about is how we engage our innate logic. Human beings are naturally drawn to the often beautiful symmetry of logic. Sometimes they're dragged kicking and screaming, but in any case, engaging with logic is a natural part of the human condition. Even with incredibly simple everyday problems we take for granted, we make use of some kind of logic. The logical response to feeling hungry is to eat. The logical response to feeling tired is to sleep. Now let's reach a little higher and talk about how we can go about solving more complex problems. The first technique we'll go over is breaking down a complex problem into smaller, manageable problems. Sometimes we come across tasks that seem so big that we don't really know where to start. In cases such as this, it is very useful to deconstruct the main problem into smaller problems that you can prioritize and tackle individually. In his CS50 course at Harvard, which is available online through edX.org, and you should totally take it because it's free, Professor David Malan recounts a classic example of this approach to logic. Before everyone and their dog had a cell phone, every year you got a gigantic book dumped on your doorstep filled with yellow pages and phone numbers. This was called a phone book, and it had lists of everyone in the area's registered landline organized alphabetically by last name. Now, a landline meant the phone was physically connected to the phone network via a phone cable. Anyways, this book was huge. Let's pretend for a minute that you wanted to find the number for Robert Smith. One surefire way to find him is to start from the very beginning and read every single name until you find Robert Smith. But that would take forever. You could speed things up a bit by skipping 2 pages or 3 pages until you get there, but then you run the risk of skipping over him, and it would still take a while. What if we open the phone book to see what looks like is the very middle and see where we are in the alphabet? Then we can determine if we search one half or the other. And that cuts our problem in half. Well, what if we did that again with the half that we determined contained the name Robert Smith? If we keep halving our problem, eventually we'll get to Robert Smith, and in much shorter time than the methods we suggested before. In this case, breaking down the problem was itself a solution. Now let's look at another example, more familiar and recent in memory, our cryptography assignment. You were tasked with writing a Caesar cipher program that could encrypt, decrypt with a key, and decrypt without a key. Looking at the program as a whole is a little daunting, so how could we chunk or break down the program into smaller, achievable parts? Well, first, there is the structure. I need to be able to select one of 4 options and have something happen. Either encrypt, decrypt with a key, decrypt without a key, or quit. Now, setting up a basic if-elif structure with simple print statements in each block to indicate that you can successfully choose an option is a good place to start. From there, you can tackle encryption and decryption separately. After learning about how a Caesar cipher works, you hopefully gleaned that decryption is just encryption in reverse. So how about tackling encryption first? But how to encrypt? You know you need an alphabet and some way to assign a number to each letter. Aha! A list or a string will do that for you. But before messing with any shifting business, why not prove to yourself that you can type in a word and print out each letter's index number in the alphabet? After that, see if you can print out a shifted index number, then eventually a shifted index letter, and voila, you figured out encryption. Another technique to use alongside this breaking down a problem is visualizing the different parts by sketching or writing them down. Now, this is where ample whiteboard space comes in real handy. Don't try to tackle a tough logical problem all in your head. I guarantee you don't have enough RAM up there for that, and you'll burn out quick. System overload will shut you down and you'll stop trying to solve the problem. Even if it's just a piece of scratch paper, start taking your ideas out of your head and putting them into the physical world. It makes more room for abstract and logical thinking if you do. Using physical media like whiteboards or paper to store your thoughts while you observe them with your eyes and make sense of their relationships is absolutely invaluable. A technique that you may call on while observing your thoughts is working backwards. The human brain has a knack for pattern recognition. Disrupting that pattern by looking at things from another angle or in reverse can reveal new thoughts, relationships, or patterns that you would not be able to recognize otherwise. This is a technique often used by grandmaster chess players, and if it's good enough to solve a tough chess problem, it's good enough to solve a lot of different kinds of problems. The last technique is something that you want to apply after a problem is solved. Write down the steps you took to solve it. Just like there's not enough RAM in your head to solve a complex logical problem completely on its own, your long-term memory is also precious space. It's likely that how you solved a particular problem will be overwritten with an awesome memory of spending time with friends or family. In which case, if you don't have it written down, it will be lost forever and you may have to relearn it again. Wasted time! Once you solve a problem, look back and record the steps you took. You'll find that a lot of problems you face employ similar steps to a solution. New problems will simply add steps to your tool bag of tricks, making you an ever and ever more efficient solver of difficult problems. A very sought after and lucrative skill. Now, for the next couple of weeks, we'll forego any formal Python programs and focus on a handful of logical problems that do not require super technical solutions. But practicing these will help you with your approach to problem solving as you apply the techniques we just talked about. When we jump back into programming, you'll be able to use these same techniques as you solve problems using your developing Python skill set. Thanks for doing the logical thing and stopping by, and I'll see you next time in the Forge.